Greetings, folks. Welcome. The practice of statistical inference involves using information from a sample of data to say something about a larger population. One common application of statistical inference is to use information from a sample to estimate a population mean or proportion. A second application of statistical inference is to use information from a sample to test a claim that you might have about a population. When using information from a sample to estimate a population mean value, you first calculate a sample mean and then you put a margin of error around it. So here you see a generic formula for estimating a population mean. On the left you see mu, which stands for the population mean value. X bar represents the sample mean, and that's something you can calculate. You can go out and collect some data on a sample and calculate that mean value, plus or minus a margin of error. In a different video, I'll give you more specific information on a margin of error, but for now, you just want to get a general sense of what it represents. So here's a statement. Average household income in Maine was $73,598 in 2017, plus or minus a margin of error of $1,747. Since the household income value of $73,598 was based on a sample, the margin of error accounts for the fact that if you had sampled different households in Maine, you would have gotten different values. And this margin of error gives you a sense of the different values you might have gotten from different samples. When using information from a sample to estimate a population proportion, you first calculate a sample proportion. Again, this is something you could do. You could go out and collect some data and calculate a percentage value, and then you put a margin of error around it. Here you see the formula. You have an uppercase P on the left-hand side. It represents the population proportion, and that population proportion is equal to a lowercase p, which is a sample proportion, plus or minus a margin of error. In a different video, I'll give you some more details on how you calculate that margin of error, but for now, I just want you to get a good intuitive sense of what it represents. So here's the statement. 52% of Americans support Todd Gay for president, plus or minus 4%. That 52% came from a random sample of Americans, and if you had sampled a different group of people, you would have probably gotten a different value. It might have been close to 52%, but it might have been 50% or 53 or 54, or there might have even been a sample where only 48% of the people that you talked to supported Todd Gay for president. And that margin of error accounts for that range that you would get if you'd use different samples. We can also use information from a sample to test a claim that we might have about a population mean value. For instance, I might believe that students study more than an average of 5 hours per day. So that's a claim that I'm making about all students or the population of all students. To test that claim, I would collect information from a sample and calculate a sample average. I would then compare that sample average to the 5 hours, which is the value for my claim. And then ultimately, I'd be able to decide if there's enough support for my claim, or it's possible that I wouldn't have support for that claim. Likewise, we can use information from a sample to test a claim we might have about a population proportion. For instance, I've always believed that more than 60% of college students hum along when they hear a Taylor Swift song. Again, that's a claim that I'm making about all college students. Unfortunately, I couldn't go around and ask every single college student in the world whether or not they hum along when they hear a T-Swizzle song on the radio. So instead, I could collect data from a sample and calculate a sample proportion. I would compare that sample proportion to that 60%, which is my claim, and then ultimately I'd be able to decide if there's enough support for my claim, or it's possible that I would reject my claim altogether. When doing statistical inference, whether we're estimating a population mean or proportion, or testing a claim that we might have about a population, we're using information from a sample, and because of that, we use what's called a sampling distribution. In a different video, we'll spend quite a bit of time talking about sampling distributions.